This is V Deepika, working as an assistant professor in Reddy College of Engineering. Okay, in the last class we have discussed about the stabilization against variations in IC node, beta and VBE. Okay. Now in the previous technique I was saying that the operating point should be exactly in the middle of the active region. Okay, but there was but due to the transistor parameters of IC node, beta and VBE, there would be a change in the operating point. So the stability can't be occurred. But we can achieve the stability by using two techniques. I was saying by making the IC and VCE to be kept constants by using two techniques, stabilization techniques and compensation techniques. Okay. So the stabilization techniques are being used to make the operating point to be stable, and the compensation techniques. Okay. Now this stabilization techniques are nothing but this stabilization techniques uses the resistive biasing circuits. Okay. So that what happened, the base current would be varied by making the collector current to be fixed. We were saying that the collector current would be varied so that the operating point is being shifted either into the saturation region or the cutoff region. So the stabilization techniques uses the different biasing circuits by using the different resistors, means different biasing circuit to in such a way that the base current would be varied by making the collector current to be fixed. Okay. The next one is about your compensation techniques. Okay. Coming to your compensation techniques, this uses such as temperature sensitive devices like diodes and thermistors, etc. So these other two techniques to make the operating point to be kept stable, means what, at the middle of your active region. Okay. Now coming to your stabilization techniques, stability factor. Stability factor, in order to compare all the, means what, its stability factor indicates the degree of the change of the operating point with respect to the variations of your temperature, means with respect to your variation of your transistor parameters of IC node, beta and VBE. Okay. Such stability factor indicates the degree of changes. So now coming to the stability factors, so there are three stability factors as three transistor parameters have been affecting the stability. Okay. So coming to your stability factors, so there will be three stability factors. First one is like S stability factors, where the collector current would be changed with respect to the variation in your minority carrier, okay, by making the other two parameters, the VBE and beta to be kept constant. Okay. The next parameter is being kept as S dash, where the collector current IC would be changed with respect by making the input voltage VBE variation with the, and by making the other two parameters IC node and beta to be kept constant. Okay. The next third one is about your S double dash, where it is a change in the IC with respect to beta by making this IC node and beta has to be kept, VBE has to be kept constant. Okay. So these are the three three stability factors. Okay. Or we can write like this also, this one, change in IC by change in IC node, beta constant, by making IC node beta constant. We can even represent this one as like this also. Okay. Now let us discuss about the first stability factor, S. Okay. First stability factor, Okay. Now we know the collector equation. We can write the collector equation as IC equals to beta IB plus IC naught, where IC naught is nothing but what ma? Beta plus 1 IC B naught. Okay. Now let us vary with respect to IC B naught. Okay. Means with respect to IC naught. Okay. If the IC naught varies, changes, the collector current would be changing, as well as the base current would be changed, as well as this IC B naught. So now instead of making that one, I can just vary this collector current with respect to collector also. If there is a change in the collector current, there would be change in the beta, base current and your IC B naught. Okay. Now if you make differentiation with respect to your IC, dou IC, change in IC by IC equals to beta into IB by dou IC plus beta plus 1 IC B naught. Okay. Now I can write this one directly as 1 beta by dou IC plus this one plus beta plus 1 change in the IC B naught by change in IC. Okay. Now I am just shifting this one to this left hand side. So I can write this one as IB by dou IC. Okay. That equals to beta plus 1 into dou IC B naught by dou IC. We know the stability factor, which is S is nothing but IC by IC naught, where IC is not is nothing but you can write with respect to IC B naught also. So I can represent this beta plus 1 into 1 by S. Okay. Now I can write the stability factor S equals to beta plus 1 by 1 minus beta into change in the base current with respect to the collector current. Okay. This is your first stability factor. Now if you go for your fixed bias circuit, I have already discussed previous session. Coming to the fixed bias circuit, IB equals to RB into VCC. Okay. Now in that case, if there is a change in the base current, the VCC and VBE would remain unaffected. So dou IB by dou IC would become, means what, there will be no change there, VCC and VB would be unaffected. So I can write in the case of fixed bias circuit, dou IB by change in I base current with respect to collector current has been 0. So if you just represent in the place of this one, just put it 0 for your fixed bias circuit, then I can achieve for fixed bias circuit only, I can get the stability factor beta plus 1 by 1 minus beta into this one is 0. So I can get directly 1 plus beta as a stability factor for your fixed bias circuit. Okay. Now let us discuss about the second stability factor, S dash. Okay. Okay. Now IC, I can write IC, I have written IC equals to beta IB plus beta plus 1 ICB naught. Okay. Now this beta IB is not, I can write the base current as what, VCC minus VBE by RB. Okay. Where IB equals to VCC minus VBE by RB by applying KVL at your base circuit. Okay. So just like substituting that base current as VCC minus VBE by RB, okay, plus beta plus 1 ICB naught. Okay. So now I am just expanding this one, beta VCC by RB minus beta VBE by RB. Okay. Now plus beta plus 1 to ICB naught. Okay. This is the expansion of this one. Is it right? Now let us differentiate this one again with respect to your collector current itself. Okay. Now, when you differentiate again with respect to collector current, then what would be the equation you will be getting? Now, you just differentiate with okay, instead of doing that one, differentiate now with respect, here we have differentiated with respect to the collector current. Now, differentiate with respect to the base current. So, now base voltage VBE. So, just IC by change in of IC by change of VBE, and here there is no change. So, we can just, when you differentiate VCC beta VCC by RB, it is nothing but constant. So, there will be no change. So, I can just write it as 0 and minus beta by RB, change in VBE by change in VB makes 1. So, I can just represent it by minus beta by RB. Okay. The next here plus beta plus 1 into ICB naught. Okay. Now, just think this the minor change in of ICB naught by change in of the VB. If there is a change in the base emitter voltage, will there be a change in the minority reverse saturation current? So, will it remain unaffected? Should I keep it as 0? Please think it, ma. I will just give you 2 minutes of time, 1 minute of time, sorry. Think, should I keep there 0, nor will it be affected? Will the base emitter voltage would be affected for your that one or not? Just think, ma. So, can I represent this one as by 0? No, should I represent as maybe